Welcome to Finding Future Fit, a Prime Origins podcast where ambition meets alignment for founders, funders, and organizations looking to shape what's next. This is Opportunity Unlocked, our special series highlighting the technologies creating new paths for the next generation of companies. This series is powered by MinusOneDB, a company unlocking physics-defying data and development velocity for founders and companies everywhere. Today, I'm joined by William Wechtenhiser, founder of MinusOneDB, and Israel Mirsky, a co-founder and chief strategy officer. If you've ever been frustrated by the cost or inflexibility of building applications that work at scale, you're going to want to keep listening. We're talking about an unlock that fundamentally changes the cost of backend infrastructure and speed to market for applications at scale. Let's start with the story behind MinusOneDB. What was the unlock moment that made you say, we have to build this?
Well, Heidi, first let me just say thanks for having us. And, it wasn't really one moment unlocking anything. It was really, I think of it as like an avalanche of small moments over the course of my career. Sometimes it just feels like I've worked everywhere in tech. And so, I started off doing AI research in defense, mostly for computer security. I ran a team building developer tools at Adobe. I was on Wall Street from 2007 to 2008, helping Goldman Sachs understand their own products and their own portfolio. I was the chief software architect at Novartis Research, helping scientists cure cancer for a few years. Ended up in Hollywood at Legendary Pictures and Warner Media. And, as much as it looks like these are completely different problem spaces, completely different technologies, what I found was everywhere I went, people had the same problems. It was always the plumbing, the data infrastructure. This was what was holding people back. And, the common problems are it was too slow. As the data got bigger, it got too expensive, but also it was fragile. It was hard to change. The data wasn't clean. And, I feel like I put a lot of work into these solutions everywhere I went along the way. And, so if there was an aha moment, it was, when I left Warner Media, I said, wow, no one should ever have to build this stuff ever again, including me. And so I started this company, and what we do is we build software that helps you build the data storage, the platform that you need, and, just tries to make it easy, streamlined. That's it.
Backend is incredibly complex. I know it's a huge part of OpEx at many organizations, often even from 60 to 80%, right? I mean, how did we get here?
Yeah, so, this has been going on for a while. And one really important inflection point in the story, I think, is around 2008. You might remember when enterprises started really talking about big data, and everyone's data volumes were really exploding for many people by orders of magnitude. And suddenly we had all this data, but no one could really query it. So all of us, pretty much the whole software ecosystem, did a kind of a devil's bargain with the cloud. And the bargain was they'd make it cheap and easy to upload our data, and we'd just pay for compute when we query it. And that approach and the associated business model has really had a massive number of downstream effects. So for one, now these players make about 90% of their revenue from compute and only about 10% from storage. So there's really very little incentive to actually reduce the amount of compute that these applications use, because any reduction comes straight out of their bottom line. And it also has pretty massive implications for infrastructure and how it's been developed and how we think about how we organize solutions for running queries on large data sets. Because, for example, when you're minimizing the cost of storage, you're also sort of inevitably maximizing the separation between storage and compute, which has cascading implications for how to deal with queries.
Yeah. In many ways, Israel, that actually makes the queries almost as expensive as they could possibly be. And, so when we were looking at this problem, what we said is we don't really want to optimize for storage at rest when you're not using your data. We believe that the future is one where people will be using their data all the time, continuously. The people who use their data more are the people who are going to extract more value from it. And so we said, how can we build a platform that works for that? And so we want to optimize not for storage at rest, but for the cost of query execution on a per query basis. And to do that, really, architecturally, we made almost a completely opposite set of design assumptions, where instead of separating storage and compute, we want to put them as close together as possible. We want to have small, fine-tuned units of the right amount of CPU, RAM, disk, and IOPS that just work together. And then really, as much as possible, we want to push the work down from compute to disk because it's a couple orders of magnitude cheaper. And so, what you get is you get a completely different storage paradigm that works in a different way, but where the execution at query time can be 1/1000th the price per query, which just unlocks a huge number of things. But, so that addresses kind of the cost side of this equation, but there's a whole other part of the total cost of ownership of these systems, which is the labor side. And this is where you have, expensive, sophisticated data engineers, working on what are hard problems, but they're also commodity problems. And so, the typical data engineering stack has between 10 and 20 pieces of technology. Some of these are tools, some of these are servers, some of these are hand-built pieces of software like a batch aggregation process. Some of them are multiple different types of databases for different specific use cases. And so all of this, tooling, all of this, it leads to an incredibly sophisticated, but incredibly delicate, incredibly complicated infrastructure. And that's where most of the labor goes. And, and that's the other part of what you're talking about. So in our world, what we wanted to do is we wanted to put more things in the box. And, I'm a software guy. Like, why should humans do something that software can do? So can we have these things already predefined and already wired up to work together without any humans needing to make that happen? So archival storage, we've got it. Data lake storage, we've got it. We've got your index data stores. We've got several other specialized stores. We've got services. We've got orchestration. We've got operations. All of this stuff's in there. And that's just that much stuff that you don't have to build yourself. So, and that's where you save, 80% of the labor to go with, 90+% of the compute, which is just as important.
And all of that is sitting behind an API that a front-end developer can operate. So, really the level of simplification for building scalable apps is pretty dramatic.
Israel, when William pitched that vision to you, what clicked?
When I realized what I was looking at, my first thought was, I need to go talk to some of my friends who are at major consulting firms, because those guys, if you're at like a major data engineering consulting firm, you can go to everybody that you've done a data engineering project for in the past 10 years and say, would you like to spend 95% less on AWS compute going forward and have like 90% of your data engineers do something user-facing instead of maintenance? And everybody who's paying attention is going to say yes. But it's even more exciting in many ways for startups, because so much of what startups spend money on in between seed and like Series A or B is just fixing whatever sticks and wire thing they put together in Postgres or MySQL when they were building an MVP and making it scale. And if they're lucky, at that point, the cost still makes sense. When you can build an application that scales to exascale without hiring 90% of the data engineers you'd otherwise have to, and you can keep the kind of line on your compute cost basically flat as you scale up, you can skip whole funding rounds on the way to being a successful company. And that's incredibly good for founders. And I think also for customers and for the public, you can take those, whatever it is, 40, 60% operational savings and use them to compete on price with established players. And then William and I talked about open sourcing it. And that's when I really got excited, because, for one thing, when you reduce the amount of compute necessary to run queries by a couple of orders of magnitude, another thing that happens is you really significantly reduce the amount of energy that you need to use to run queries. And so there are significant implications for energy usage in data centers of switching over to an architecture like this.
How does that connect to what organizations and founders need today?
Yeah. So in addition to dodging the massive cost trap on the way to scaling, right? Startups live and die by how fast they can iterate. If querying your own product data has significant costs, and like you should be gathering a lot of data for your product to understand how users are using it, you're going to slow down. If building new features means reorganizing the way your backend works, you're going to slow down. If you can remove those penalties and shorten the feedback loops, everything gets better. Everything goes faster, from features to model training to revenue experiments. And I think that's going to have a really significant set of implications on how successful and how survivable being a startup is for many founders.
A lot of our listeners are looking for how to keep up or the tool that will help them reshape what they're building. What does MinusOneDB unlock that wasn't possible before?
There are things that we do that I think of as table stakes, where, as Israel said, we want to scale from, startup to, exascale. And along the way, one of the things that really matters is every operation should be constant time at every size. So if you can query the data in 200 milliseconds for a terabyte of data, you should be able to query the data in 200 milliseconds for a petabyte of data. If you can rebuild an entire environment in 3 hours at a terabyte size, you should be able to rebuild the entire environment in 3 hours at a petabyte size. And so that's one of the things we deliver. You get to have one single development paradigm, one single, performance paradigm for all of your software, and, your cost scale linearly with data set size, but your model doesn't change. Secondly, I think the world is streaming now. I don't think you can survive with batch business processes that you run once a month, once a quarter. And so our system, all those bits we have wired together to work together out of the box, everything's always near real time, start to finish. So your data shows up in seconds and you have it available immediately. And again, that's just something we think is table stakes. Once you shift over to that model, you're never going to go back. It just builds better software. And then, finally, and this terrifies me because I've worked with this and I've seen this. We talked a little bit about how expensive the query execution is on some of these existing platforms, but it's also unpredictable and unknown in advance since it's all based on usage. So you don't really know what you spent till after you've spent it. And it creates two problems. One is, for me, that's terrifying. I run a business here. I don't want success to put me out of business. But that's the other problem is now, the more your customers use your data, the more you internally use your data, the more it costs you. And that creates a disincentive to use it. So we wanted to build something differently. Our stuff is based on capacity. You provision it. You know what your costs will be up front. And for almost all use cases, it's completely an all-you-can-eat model. You won't even use up the capacity that you license on a per query basis. So you just run your stuff against it, and you never think about it, which is great. It's freeing. It's liberating. And then so we've got our table stakes. But then, what does that really mean? And and this is where I get kind of excited because, when you cut the cost of query execution by several orders of magnitude, what happens is you enable yourself to run many, many more queries. So if your analysts and your data scientists used to run dozens of queries per month, well, now you're going to run thousands or maybe millions of queries. You're going to have AI agents generating queries and looking at the data that returns and doing pattern matching and anomaly detection. And those are things you just couldn't afford at all in the previous paradigm. And so what is that going to let people do? I don't even know, And then on the other side, on the engineering side of the house, these giant scale data warehouses and this giant data infrastructure, people talk about kind of automating it and building it with DevOps best practices, but in practice, this stuff is not usually easy to replace, recreate, destroy, start up again. And so we built all of this stuff with a mindset that everything should be, I like the word fungible. Everything should be fungible from the get-go. You should be able to tear down a data environment and rebuild it in hours and be back up and running. You should be able to create a copy for your friend to use and destroy it when he's done. And so again, what does that unlock? Well, we don't know. No one's ever been able to do that at petabyte scale. So what are people going to build using that? And then just finally, I'll just say, some of the things, just a small number of the things we're talking to people about that I think are cool are, so with these capabilities, you can do parallel scoring of explosions of machine learning models, like any number of machine learning models all at the same time. You can drastically simplify data transformation and cleaning, where you can get the best of both worlds for both ETL and ELT approaches, and you can do it with a fraction of the human work that it used to take. All these GenAI applications, they all have streams of data that's all text, and you can, with our platform, you can introspect those streams as they're happening, so you can monitor them. You can add access control. You can take this stream of data and feed it back into the AI training algorithm so that it gets smarter, not just when you build your next version, but in real time. And then finally, there's exciting things where people are looking at how do we how do we really properly share data for the first time in the age of the internet? Like, can we federate our data where you have data, I have data, we can share, we can use it with across industries, across data types. So there's lots and lots of interesting things. And I'm sure we're just scratching the surface.
Yeah, absolutely. And, speaking of like scratching the surface, I feel like for many founders out there, is there a type of founder product moment in the startup's journey that I know we just touched on a lot of those particular moments, but for those companies, when is the best time to engage with you all? Like, when is that moment for them where they're like, oh, either I should have done it then, or I need to do this now?
Well, there's probably three. So the first one is kind of stage zero, right? You're a founding engineer. You want to prototype something without having to worry about the architecture, frankly. You just want it to work, and you want it to work as the thing scales. You can point your application at -1 dB, and you can just build and ship. The second stage is probably sort of escape velocity. So you may have hit product market fit, and your data volume's exploding, and your data center bills are starting to look like a hockey stick, and suddenly you can't afford success. That is a moment where founders come to us and say, help, like, how do we fix this? And that is the thing that we can do. And the third is, like, if you've been limited by some of these things that we're talking about here, like say you're doing machine learning, but because of the cost of scoring models, you're only doing a few models a day, but you'd like to be able to do hundreds or thousands. And that's potentially differentiating for your app or your use case. Or you're trying to bring in streams of data, and you're realizing that the recency of those data types, if you could improve it from like weekly or daily and make the recency like real time, that it could have a really big set of implications for how valuable or how effective the way you're using it is. That there's a lot of examples in advertising where that's the case, where if you can make data recency on the back of behavioral data something that's like real time as opposed to something that's like batch daily or weekly, it's going to work a lot better. And so, that is another place where, some of these unlocked use cases mean that the value proposition for your application or the features in your application are fundamentally different. That's also a place where people come and talk to us.
Can you share a moment that you've seen this used in the wild? Maybe a founder or team that made a leap because of this unlock?
Yeah, sure. There was a customer that we've been working with for years now, actually. And, when we met them, it was a very classic startup story. They had a really creative, really innovative idea. It was very sophisticated, a lot of complexity to it. And, they were just not able to iterate at the speed that they needed to as they were, in the search for product market fit. They'd been kind of painted into a corner. And the reason in this case, it wasn't data size, and it was somewhat performance, but it was really just the ability to build what they needed quickly enough, figure out what was working, and change it. And so literally, and this was a product to be sold. This is an enterprise product, so it's being sold to very large companies with sophisticated privacy, security requirements. And so we started talking to them, and we identified what they needed, and we said okay. And so we worked together for a little bit, and we were able to, using our technology, build them from scratch. We started over from zero. We basically took everything they'd done up to that point as a prototype. We learned some lessons, and they had an enterprise-ready MVP that they were taking out to their customers 9 weeks later. And and since then, they've been able to iterate. They've been able to add things. I mean, one of my favorite examples is at one point they were pitching a customer that was a Spanish language customer, and we said, oh, wouldn't it be kind of cool if you could just show them the stuff in Spanish? And so using the services and the technology we built for them, we added a localization feature over the weekend. And so they showed it to the customer Monday. And that was typical of the speed that we were able to deliver. They when we started talking, they expected it to take 6 months. So, take that 9 weeks that we shipped their product for them. And that's a meaningful difference if you're a startup founder, and not just to be able to do that at all, but to do that when you're stuck in the mud, when you've now gotten to a place where you're, one of these moments Israel described where you're stuck, and to be able to unlock yourself and just get moving, I think it was transformative. So.
Wow, that sounds incredible. Is there a type of founder, product, or moment in a startup's journey where this becomes especially valuable?
honestly, if you've got a lot of data, including like product data or behavioral data, or you aspire to have a lot of data in the future, we really should probably talk.
Yeah. Well, I mean, I would focus on time to market, time to feature. I would really, like Israel said earlier, speed is life for startups. And so, when you take the combination of features we have and the ability to help you get moving quickly with the scalability and performance that we offer, you can really build out some very sophisticated startups. So, we've looked at if you wanted to build your own competitor to Twitter or Facebook, you could probably build it for somewhere between 1/10,000th and 1/1,000,000th of their hardware costs, and that may make that possible for someone where otherwise it would just be impossible. We like to joke among ourselves that, our whole business is really kind of a list of startups in search of a CEO where there's all this stuff you can build. We're just waiting to see who does what with it.
Looking ahead, where do you think this is going to take us? What do you see as the next big opportunity created by this shift? Will it be the next Facebook? Will it be? I mean, I can only imagine, really.
Well, that's really what keeps us working on this, and that's what's so exciting is with a paradigm shift like this, it's hard to know, but it's super interesting because the big things get cheaper, and so you can do things you couldn't do before. I like to talk about the Jevons paradox, which I'm certainly not the first person to talk about that in relation to data. Where as things get cheaper, people will just find more and more uses for what they can do and what they can unlock and how they can become smarter. And then we've talked about new projects where making them faster, making them cheaper, and by the way, specifically for not requiring all the specialized skills, it de-risks startups, which is good for founders who can know what they're doing. They can take their company in new directions, and they can take risks they couldn't take otherwise because their ability to iterate and their ability to predict and manage their costs is much better. They can skip rounds of funding, but it's good for VCs too, because you get more bang for your buck. When you put money into a company, they do more with it and you can see the results more tangibly, but I would say really the most exciting part of all this for me is we don't know, what I call them the kitchen table ideas. Like someone somewhere is sitting there with a drawing on a napkin right now. And, a few years ago, it might've taken $1.5 million to get them to, a production ready MVP. And now maybe they can do it for $50,000. How many more ideas are going to go to market? How many more people are going to say, I can do that? And where is that going to take us? The answer is, we don't know. Like we're going to see what all these creative people can do. And that's what I'm really excited about.
What is the one thing you wish more founders knew?
I would say, don't hire an engineering team. With the improvements in AI to build your user interface plus our software, and you just don't need it. You can get up and running easily. You can hire someone off Upwork. You can build your app. You can take it to customers, and you can build your business. Don't hire a CTO yet. Don't hire an engineering team. Figure that out later. Build your engineering team after you have product market fit, and that's de-risking early stage startups. That's what I would say.
And what's a belief that you held 5 years ago that you've completely changed now?
Well, I was pretty wrong about the timing for all of this happening. I thought, 5 years ago, if you'd asked me, I would have said, oh my God, everyone in the world has these huge problems. No one can use their data enough. I think what I've learned is people were still building their software. People were still building their data lakes. People, but I think I hear more and more now, where people are saying, hey, we spent some years building our data lake and now we're using it. And whoa, look at the cost. Like, hey, we should do something about this. So I think I thought it would happen faster than it did. I'm probably not the first or last founder to say that.
Yeah, I think most of the time the market timing ends up being some of the sticking points. Thank you guys. I know we're kind of wrapping up on our session here, but I want to thank you guys for joining us.
Thank you so much, Heidi.
Thanks, Heidi.
If you're sparked by what you've heard today, let's connect. This is Finding Future Fit, where high leverage builders and backers discover what's next. If you're building it, funding it, or enabling it, we want to hear from you. I'm Heidi Hysell, and I'll see you next time.